Well, hello and welcome, or welcome back. It is time once again to try to fix something. And today on the workbench, we are once again looking at our old friend, a dead PS5. Or I guess I should say PS5 fat at this point, but anyway, I'll just call it a PS5. But yeah, this is supposed to be totally dead, and I believe it is. Power is connected. We'll just get right into it here. Oh, eject. Okay, so we do get an eject beep and a power beep. So we're not totally dead. There's some life going on in there. There's a few electrons moving around. But we're not doing much. No lights. No lights. So I don't know what that means. But not going to be a power supply problem, I don't think. Let's get those covers off and let's just see if it's been messed with before. Well, the side plate is off. And yeah, well, that looks encouraging. It does look a little bit peeled up on the corner there, but it appears to be intact. I don't see it saying void everywhere. We may be lucky with this one. Looking promising that it has not been messed with before. Okay, let me get on into it. This does look like to be a 1215 model. You can tell by that small area, that cover. Okay, let's get on into it. All right, well, I am down to the circuit board. And if the intact warranty sticker wasn't enough evidence that this thing had not been tampered with, I can say there are no screws missing. It looks totally clean. I don't think this thing has ever been touched before since it left the factory. It is an EDM30 board I see there. So let's get it inside of the workbench, see if we can figure something out with this thing. Well, here we are inside the workbench. Ready to take a look at this EDM030 board. And the first thing I think I want to do is take a look at its current draw. I just like to see that, see if it's initializing properly or not. So if we look at channel 1 over here, turn it on. Ooh, 50 milliamps and up through 3. That looks high. 360. And we hang there. But that looks odd. 51 milliamps. And that's what it was drawing as soon as I hit the power button. That's not normal. See, 50 milliamps there immediately. That looks somewhat normal. They over, should be right at 300 though. Maybe 320. So 51. That looks. I'm gonna say she's drawing. 40 milliamps too much at least. Okay. Do we have a short of some kind? Well, that's a good possibility. Let's take a look around the board and just see if we can figure out. Disconnect our power leads. I mean, it's not dead, obviously. It's doing something. The south bridge is trying to do something. But it's not really quite right. Get these leads all. So, where to begin? Well, I know we have 5 volts. It wouldn't be drawing that, the majority of the rails are coming up. If it's, drawing over 300 milliamps like that, it has to be. It's trying to start up. What about, this supply right here? I'm wondering about, the south bridge is not dead though, because it's trying to do something. Let's check some of these rails around this dialogue chip. Not sure if this may be a dialogue, it may be a rich tech. I can't tell without looking under the microscope. But like this should be 3.3. It is not shorted. 1.1. Now that was the ground. 1.1 is not shorted. Over here, it's like a 2 volt. Just want to hit some of these rails. Some of them I'll have to get under the microscope to confirm. But for right now, I'm happy just seeing if I hit any shorts around that chip. No, that was ground there. That looks normal. So nothing jumping out there. None of them, like 3.3 is fine, the 1.15 is fine. I think that 2 volt rail is fine. Obviously no short on the 5 volts, or it wouldn't be doing much of anything. No short on the 12 volts, of course. What around the HDMI encoder I see? No. 437 ohms there. Definitely nothing shorted. Not there. Just going to hit a few other spots. This goes into the APU. I think we're good there. Shouldn't be anything to do with RAM or APU really, because we're just trying to get it to initialize normal, and it's not happening. We can turn it over. That must be ground there. 4 ohms, 2 ohms. That may be normal, but I'll keep that in mind. Maybe normal. I may have a 30 to compare to. Let's flip it over and look at the other side. Let me poke around the back of this south bridge a little, but I just don't think that's where the problem lies. Hit some of these small inductors that are carrying in the voltages. Nothing shorted. This one may have battery voltage on it. Is it that one or is it that one? One of these has battery voltage on it. I'm surprised it's not beeping there. Unless the battery is dead, which I doubt. Nothing shorted. This is the back side of the HDMI encoder. Because she's definitely drawing too much current. Here's the power supply for the SSD controller. Pretty good glare on it there, don't I? Oop. Let me move that light off to the side or something. Which I don't think is a problem, because it acts like it's trying to load its software. If you're getting 300 milliamps and such in that area, that's ground. Sure doesn't seem right, drawing 50 milliamps at idle. 50, is it 50? That doesn't look right. But, see, this is the Wi-Fi. Oh, Wi-Fi module. Yeah, that's not right. Okay. So we have a couple of shorted caps on the back side of the Wi-Fi module. And so that's going to be our issue. And I believe this will be a module that only uses a single supply, uses 3.3 only. Because I see some missing capacitors because they were not needed. That's where the capacitors would be, bypass capacitors for the 1.8 volt rail. And this one doesn't use it. So there's a separate 3.3 volt supply, which I think is right here, right below the south bridge. I think that's there's a 3.3 volt supply over here to run this, to power this south bridge. Comes out right here actually. But this is a separate one for running the Wi-Fi module. And let's see, do you have a short there? No? Okay, there's the short. So this must be on the input side right there. Small capacitor. On the output side, right over here. So we could have a shorted capacitor. Could have a bad DC-DC converter. We could have a shorted Wi-Fi module. I can get set up and we could just inject and see where the heat comes from. If it's inside that metal can of that Wi-Fi module, Bluetooth Wi-Fi, it's going to be hard to see it. I mean, it will eventually radiate out. You'll see it. But let's see. How about let's take a quick look under the microscope and just see if any capacitors just look, you know, if any of them hold up their hand and say, hey, it's me. Look no further. Doesn't always work that way. It probably won't work that way this time, but why not? Let me get my microscope set up. Let's see. How about some lights? All right, so here's the Wi-Fi module. And yeah, I'm getting a short on both of these caps and on capacitors on the back of it. Wait a minute. There's a solder ball hanging out from under this thing. Kind of odd, but yeah, just something left from the factory. I need to get it off my bench though, because if I don't get it off the workbench, it will wind up stuck to the back of a board somewhere. In a place that we probably don't want it. Okay. All right, now back to work. I do try to keep solder balls off the workbench, though. I mean, it's like nothing good can come from just pieces of metal floating around on the board. I mean, on your workbench. All right, so there's the Wi-Fi module. Here's the power supply for the Wi-Fi module. And I'm going to guess that fuse is intact, because we wouldn't be having that high current draw if it wasn't. Let's just confirm it though. Continuity mode. How about our fuse F7002? Yeah, still good. And like I was saying earlier, I believe this is on the, yeah, you can see the 5 volts where it goes in right here. No short here. But on the output, yeah, we have it very short. A fraction of an ohm. So yeah, no problem if we inject, no problem in getting enough current. You know, at like 1 volt, no problem getting enough current to produce enough heat. Okay. I guess we can just inject right there on that capacitor. Crank up some stuff. Just a convenient point. I don't see a capacitor looking obvious, unfortunately. Let me find my convenient wires, and I like to move the cables out of the way for the 12 volt channel so I don't accidentally grab those while I'm injecting, because the other channel is normally set, my channel 2 is normally set much lower. Let me take care of that though while I'm here. Looks like it's set for 4.2 volts. I think I was working on a switch. 1 volt will suffice, and I'm going to go ahead and turn this current up to, let's just say 1 amp or something. We'll start there. We'll give that a start as soon as I can find a piece of solder. Don't need much. There we are. Just going to tack this wire on there. There we go. And I'll try to be gentle and not snap off this capacitor. Well, darn. Just realized I have packed up my thermal camera. Yeah, I am in the process of moving right now, and I have packed up quite a bit of my gear. So, yeah, it's not here. So we're going to have to use alcohol to see if we can locate this short. Okay, I am connected. Let me turn this supply on. Yep, we get a full 1 amp of current, 0.08 volts. So it's quite short. That's not giving us a lot of heat. I'm going to crank this up to 2 amps. And at 2 amps, I get 300 milliwatts. Still not a lot of heat there. Still not a lot of heat. That capacitor there. No, there's some small ones around, but I doubt it's them. No, let's go over here around the Wi-Fi Bluetooth module. Is it you? No. Is it you? I'm going to say no. Okay, let's flip the board over, because there were several small capacitors on the back side of the module. Maybe one of those. They all look pretty healthy though, I'd have to say. We'd have to be really lucky for it to be one of those. I don't usually get that lucky. All right, I'm gonna put a little alcohol on that one. I don't see anything happening with that alcohol. How about you? No. Still drawing full 2 amps. But it's such a low resistance, there's not a lot of heat being developed across, you know, the short. I think that's the last. I see some small capacitors back there, but it's kind of the last of them behind the Wi-Fi module. Nothing jumping out at me. I mean, alcohol is evaporating, but that's kind of what alcohol does. Yeah, you can see it evaporating off of it, but it's evaporating slowly. That's 0.143 volts at 2 amps. Oh, the power dissipation has dropped down to 0.284, so it's changed a little. So whatever is dead is changing as we put some heat through it. Because we're going to have a hard time seeing it if it's inside that can of that module. I'm just not seeing anything. I mean, I see some evaporating there, but and to remove this module, let me look at the other side again. To remove this module, I would heat up the back of the board right behind it to remove that module. But you can see what's behind this module. All these little plastic connectors for the antennas, and they will just disintegrate. So that's not an option. We'll have to heat it from above and just be very careful. I don't see any other bypass capacitors around here. And this is a, you can see the part number there. And I don't know if I have one of these. AWXM546. I didn't see, of course it could be the chip, but let's put some alcohol on that chip. I doubt it though. Power on. 2 amps of current. No. It is basically 1/4 of a watt right now. That's what we're dissipating somewhere. I don't think there's, just look at the other side of the board behind that DC-DC converter. I don't think there's any capacitors back here though. You can see right in here, here's where the 1.8 supply would be. If this Wi-Fi module needed it, this would be populated to provide 1.8 for the module. And I'm assuming if I need to use an older module that required both voltages, I could probably populate this and use one of the older modules that required both voltages. Haven't tried that though, but in theory, if you populate it properly with the right ICs, it should work. Let's hope it doesn't come to that though. Yeah, I wanted to see if there's any capacitors on the back side of that DC to DC converter. I don't see any. So we are left with the Bluetooth Wi-Fi module. I don't see it being anything else other than the module itself. Let me get set up to get that removed. Alright, let's see if we can get this Bluetooth Wi-Fi module off. I do have it hanging off the edge of my workbench. I don't plan to put a lot of heat from the bottom. I probably will occasionally put a little bit of hot air from the bottom just to help move things along, but not a lot. I can't use a lot because of the plastic connectors on the bottom, but it gives me the option of using a little bit of heat. Getting some air cranked up. Yep, I am going to go maximum heat and air on this. It's going to take a good bit to get this off. I'll give it a little bit of heat from the bottom. Not a lot. And there she is. I'll let that cool off a little bit and then we'll see if our short is gone. So our Wi-Fi Bluetooth module has been removed, but has our short been removed? We shall know momentarily. If I can get a good ground. The output was right here. No. No. Well, darn. So I removed that module for nothing. We still have a short. I would have bet anything it was that module. Yep. Well, you know, the thermal can would have made this much easier, but I don't have it. It's across town in a storage locker. Well, let's see. The easiest thing to do would be to go ahead and remove this IC. I mean, it won't take but a second to remove that, and or some of the caps. Now that was a gigantic waste of time. Well, it didn't take that long, but still. Let's see if we can get them. Get my nozzle back on my hot air station. And we will remove that chip. I mean, I couldn't tell it was getting hot. Yeah. No, with alcohol, I couldn't tell if it was getting hot. So right in here, let's just remove the IC. I'm going to use 400 Celsius for this, maximum airflow. So it was the chip, maybe? We don't know. Just don't know. Okay. Chip is off. And how about our short? Nope, still there. Okay. Capacitor. Still shorted. Okay. Still shorted. So is it going to be one of these little caps or the ones on the back? I mean, I'm here. Let's just see. The board's probably still kind of warm. Park that one right there. Makes that board is hot. And we'll just park that one. Oops, not there. Right there. All right. Oh, short's gone. Well, that's the wrong pad. Wrong pad. Short's still there. Short is still there. That's the pad for the 1.8 volt rail we don't have. The short is still there. I mean, there's a path back this way through this inductor, but I don't see anything else. You know, there's nothing else tied there. It would just be the chip. So we lifted those. All that's left, if I'm not mistaken, are these tiny ones on the back of the board. Is this on that rail? Oh, that is on the rail. So we have these here, those two, and we have some right up here. I don't remember if I looked at those, put alcohol on those before, and I just don't remember. You have to be careful with these plastic connectors here. Ugh. Let's see. Yep, missing that thermal cam right now. Sure missing that thermal cam. We've got a plastic connector here we have to be careful about. I'll put some tape over that. And I may put some over this. Let's see. Okay, got that covered. I just don't know if that rail should not go anyplace else but the Wi-Fi module. I don't think. I don't believe it does. Okay. Let's just remove all three of these. Let me add a little leaded solder just to help. Okay, just a little. Let's just get to it. Oops, stay right there. Stay right there. All right. Any change? Yes. Yes. So one of these. This one? No. No. Yes. That was our culprit right there. Okay. I'm going to assume that these two are the same value. So I'll get a reading off of this one. See if I can do that with my meter. So I've already put my smart tweezers up. I do have another pair of tweezers I could use. What does this say? It says I just knocked it off the board. Where'd it go? It was barely stuck there. And now it has left. How far could it have gone? It's not on the board. Well, that's just frustrating. That was the good one. Well, it looks like I knocked the end cap off of it anyway, so it's no good anyway. So let me, this is the bad one. Let me find a donor. Oh, I'm in capacitance mode. Resistance mode. No, this is continuity. Okay, let me find a donor for 2 capacitors, and I'll try to get a value for you. Well, I did manage to find that capacitor. It had traveled a lot further than I thought it did, but I'm sure this is it, though. It is missing part of the end cap. Let me see if I can get a reading on it, though. 9.9 microfarad. Yep. 9.9/10 microfarad, so that's what it is. Okay. I'll see if I have some new ones. Don't know if I do. I have a few new caps laying around. Of course, this is only across 3.3 volts, so what size is that? Is that 06, 03, or is that bigger? Is that the same size? Oh, where'd it go? Right there. Is this the same size? No, this is bigger. This is the 10 mic 0603, so that must be 0402, 10 microfarad. Oh, I do see some 10 microfarad, 6.3 volts, 0402. How about that right there? Yeah, they're rated at 6.3 volts. I think that will work. All right, let's get those installed. Well, all capacitors have been replaced or reinstalled. The DC-DC converter that generates the 3.3 has been reinstalled there. I think it's fine. I don't see a short anymore. Our original Bluetooth Wi-Fi module has been reballed and reinstalled. So we are at a point of testing, I believe, unless I've forgotten something. So let me get my leads hooked back up. Observing the correct polarity, I hope. Yes. Let's just see if we get a normal initialization now. Let's just see. Nothing. Okay, did I get alcohol up under my south bridge? There's a good chance. Just a second. Nope, that's not the problem. No alcohol. If we follow these wires, that goes to channel 2. So, yeah, wrong channel. That's kind of why I separate them, though. I guess so I can't grab the high voltage when I'm needing the low voltage, and vice versa. Let's try this. Maybe that works better. Now we have the right channel connected. Let's see what happens. 321. That looks beautiful. Come back down. And back down. All right. All right, I like that. We're ready to test this. Let me get it back out there on the chassis and see what it does now. Well, here we are back out in the garage. I've got the board back in the chassis here. I think I've got the required cables hooked up. We probably should hook the fan up. I mean, I'm not going to leave it on long enough to overheat, but I do like to see the fan spin. Kind of get it where it won't go flying. Okay. Yes, I think we're ready. Earlier she would just beep. What does she do now? All right, she's turning on. Fan is spinning. Will we get something on the monitor? Yes, we will. PlayStation logo. Beautiful. All right. So just the bad capacitor. Okay. Well, let me finish putting it all back together, and I'll give it a more thorough test. How's that sound? Well, this PS5 is fully reassembled and seems to be working well. The controller is working just fine. So our Bluetooth module is working, and it can see my Wi-Fi hotspots no problem. So I'm installing a game off the Blu-ray. I think she's going to be just fine. Well, I hope you liked that one. So it was so interesting, educational, entertaining, or any of the above. If you did, please give me a thumbs up, and I will see you in that very next repair. So long for now.